The electrons of an atom can exist only within certain energy bands. They cannot exist in band gaps. On your screen is an energy band diagram for an unexcited atom in a pure silicon crystal. It has not been allowed any external energy. This condition occurs only at a temperature of absolute 0 Kelvin. However, at room temperature, sufficient heat, that is thermal energy, is provided to some, not all valence electrons to jump ship. That is, they move into the conduction band. You can see that here. However, notice that a vacancy is created in the valence band from where the electron jumps. This vacancy is called a hole. It has a positive charge which is not shown here. The electron and the hole are called an electron-hole pair. Recombination occurs when a conduction band electron loses energy and falls back into a hole in the valence band, like this. So a piece of intrinsic silicon at room temperature has, at any instant, number of conduction band free electrons that are unattached to any atom and are essentially drifting randomly throughout the material. There is also an equal number of holes in the valence band created when these electrons jump into the conduction band. Now, when a voltage is applied across a piece of intrinsic, that is pure silicon, then these electrons start to flow in one direction. This is called the electron current. However, not all electrons are free to move. Those still stuck in the valence band are not free to jump into the conduction band. Remember that not all electrons make the transition. So what do these electrons do? Some of them move into a nearby hole, an action that requires little energy. In turn, when they recombine with a hole, they create another hole in the process, like this. Therefore, we can say that effectively the hole has moved. In reality, the hole does not move, but it looks that way, as you can see in the diagram. It is really the movement of electrons, not the holes. This results in a current called hole current. It is the second type of current in semiconductors, the first one being the current due to the electrons in the conduction band that were flowing after we applied the voltage, these ones. Remember that the hole current is caused by electrons in the valence band. The current is not caused by holes. Holes do not move in semiconductors. Some of you might wonder how the mechanism is different from conductors. The thing is, in conductors, all valence electrons are free to become conduction band electrons since the two energy levels overlap. The valence electrons, unlike in silicon, do not belong to any atom, but belong to the structure as a whole. They form a metallic bond with the positive ion cores, which are atoms stripped of their valence electrons. All the valence electrons in a metal are free to move, unlike in silicon. Thus, when the voltage is applied, only electron current flows. There is no hole current because there are no holes in metallic structure. The movement of electrons results in positive ions, not holes, because no covalent bond exists between atoms.